Okay, question 19, which is saying you've got this quadratic here and you want to write it in this form here. This is completed square form, okay? Now, you've got quite a lot of unknowns here. You've got C, D, and N, which are all unknown. And maybe you think, well, what do you even do here? Just begin by completing the square of this here. Now, to complete the square, ideally, you just want to have x squared without the 8 in front of it. So let's just go and factorise out an 8 from the x squared and also the 20. Now, if you factorise out 8 from 20, you're going to write it as 20 over 8 with the x still there, and then just leave the plus n on the O. Now this is good because you can now go and complete the square of the bit in the brackets, okay? And just remember you've got the 8 on the outside. Now I'm going to write 8 with a big bracket and you'll see why. Now completed square form is always x and then something squared, and you half this coefficient here. Now actually 20 over 8 you can simplify. That's the same thing as 10 over 4, which is the same thing as 5 over 2. So you've got 5 over 2x. Now you half this coefficient, and if you half 5 over 2, it's going to be 5 over 4. And then you take this part here, you square it, and you make it negative. So 5 over 4 squared will be 25 over 4, and you make it negative, 16. There we go. We can close the big bracket, and you've got the plus n on the end. Now you just go and distribute out the 8 to the bracket and 8 to the fraction over here. So you can write this as 8 lots of the x plus 5 over 4 squared. And then 8 times by minus 25 is going to be minus 200 over the 16, and you've got the plus n on the end. Now this part here, you can simplify it. You can just keep halving it, so you've got 200 over 16. If you're not sure what to do, just keep halving it. So 100 over 8, which is 50 over 4, which is 25 over 2, which as decimal is going to be 12.5. So we've got 8 bracket x plus 5 over 4 squared minus 12.5 plus the n. Now I've actually got some of the missing values now because I wanted to get the number before the bracket, which is the 8. So c must be equal to 8. I've also got the d part, which is 5 over 4, which is nice. And then I want to go and get the value of n. And the n part is the end number, okay, which is going to be equal to 3. And this is my number part. So minus 12 plus n must be equal to 3. You're sort of equating coefficients here. So this plus 3 here, let's do a different colour. This must be equal to this over here. That's your number part. So we can go and create an equation here and say you've got minus 12.5 plus n must be equal to 3. And then add on that 12.5, so n must be equal to 15.5. And they are going to be my 3 values. Okay, so that should be it. Check the mark scheme. So 8, 5 over 4, and 15.5. Good. And my iPad is now not lagging, which is even better. Good stuff. Question 20. You've got a circle theorem question. Now, when I get this kind of question, I'm not even really reading the question. I'm thinking, what circle theorems can I spot from this question here? Because all the information is given on the diagram, that's fine. And you want to go and get the radius of the circle. So you want to go and get basically this part, which is the same as this part here. So actually I recognise that this here is an isosceles triangle, which is going to be probably useful at some point. And also I've got this shape here. This is the circle theorem that the angle at the centre is double the angle at the circumference. So this angle here must be equal to 60, which is going to be useful. Now, I've got this triangle over here as well, and I've got this angle. Now, to get these sides here, I need to get this side down here, which I can do if I go and consider this triangle here. So this one to here, up to here. Okay, I can consider this triangle because I know that, that this angle here is 60, this is 4, and this is 5. And if I go and get PR, which is down here, let's go and call it x. And I can go and get this from the cosine rule. This is the classic cosine setup. I've got an angle with 2 adjacent sides, cosine. And let's go and call this side here A. Let's go and call this one lower a and capital A. And then these two sides must be B and C. And the cosine rule is a squared is b squared add c squared minus 2bc cos of the angle A. And then we just go and substitute. So we can just go and say that, well, x squared is going to be equal to 4 squared, which is 16, plus 25, minus 2 times 4 times 5 cos of the angle 60. Now, cos of 60 is just equal to 1 over 2. That is a exact trig value that we should know. If we go and simplify this up a little bit, we can say that x squared is going to be equal to 41. If we add those together, take away 2 times 4 times 5, that's 20, 40, and half of 40 is 20. So we can then go and take away 20. Okay, and then so x is going to be equal to the square root of 21. And that is going to be this side here. Now, it's a bit of an awkward length, but I can recognise in the question that I want to give my final answer in the form root k. So this could be absolutely fine. So now, if I go and consider this triangle down here, okay, and what have I got on this triangle? So let's go and bring this down. There we go. Let's go and just whack it down here. So this angle here is 120. I know that these sides are the same. The triangle is isosceles. Also, these must be 30 and 30 to give me 180. I'm just writing down what I know on this, and that side is there is root 21. Okay, that's right. Not very clear, is it? Root 21. Now, how can I get this here? Now, I could use the sine rule, but I'm actually just thinking, right, if I split the triangle in half, there we go. Well, that's actually going to change this angle here to, that was 150, 120, so that's going to be equal to 60 now over here, which is useful. I've got a right angle triangle. Okay, I can use a bit of SOHCAHTOA. And also, right, that means that each of these sides here, if the whole thing is root 21, this must be root 21 over 2, because I've kind of halved it. Yeah, the whole thing was root 21. That bit there's going to be root 21 over 2, because the triangle is isosceles, and that's 60. Now, I can go and get this side here. Now, I don't even need the 30 there. That's just extra. But let's just go and use sine. So if I go and label up the triangle, this is going to be my opposite side. That's going to be the hypotenuse, which is what I'm trying to find here. Okay. Now, just recalling sine. So sine of the angle is equal to the opposite side over the hypotenuse. And the angle I'm using here is 60. So sine of 60 is equal to the opposite, which is root 21 over 2, divided by the hypotenuse, which I don't know what that is. Now, I've already used the letter x. Let's just go and call this missing side y, so we don't get confused, or mixing up variables. So divided by y. Okay, great. Now, sine 60 is actually equal to root 3 over 2. That's an exact value. So you've got root 3 over 2 is equal to root 21 over 2 divided by y. Okay. Now, I've actually written this a little bit awkwardly, right? I'm actually just to make it a little bit clearer for you guys. That was not. Oh, no, I don't want to copy it. Just so you can see a bit more clearly what's going on. Let's cut this, and let's cut this. That was fine what I wrote. It just wasn't very clear. So, sine 60 is the opposite side, which is root 21 over 2. And you divide that by the hypotenuse, which I've gone and called y. Now, to rearrange this, you just switch these two around. So you're going to go and say that y is equal to root 21 over 2 divided by sine 60, which again was root 3 over 2. And this is now dividing fractions. You're going to take the reciprocal of this one and change it to times. So y is going to be equal to root 21 over 2 times by 2 over root 3. And this is nice now because these 2's will cancel, and then we're left with root 21 over root 3, which is the same thing as root 21 over 3. If you've got two surds being divided individually, you can write it as one big surd, and that's of course equal to root 7. And that's my answer. Okay, I think so. That's going to be equal to root 7, which is in the form root k, where k is a whole number 7. So this is my final answer. We'll check the mark scheme, and we are looking good. Okay, so that is the end of this paper walkthrough. Hopefully this was useful, and thank you for watching.